Hello, everyone. Thank you for coming for my talk. This is testing platforms or open system firmware, or really just open firmware. And I'm co-hosting this talk with Christian Walters from 9 Elements, and I am Sriram Ramkrishna from IT Renew. So let's get started. And so I think while we're talking about a platform for open firmware, we first should say, what is the motivation for having a platform, right? And of course, it comes down to testing itself. But specifically, I want to talk about standardized testing across near metal open source projects. And when I say near metal, I'm talking about the software closest to the metal from boot, right? So that's core boot, that turns into U-root, into Linux boot, and finally to the operating system of your choice. And so going through all this, we want to be able to test each one of these things that are close to the metal, right? And that is my driving need, or our driving need, for doing standardized testing for near metal or open source projects. Now, why do we want standardized testing? Why is testing important? I think for most of us as mature software developers, we understand why testing is important. Unit tests are important. But what is driving this whole thing now? Why do we want this now? Now, we're living in an exciting time. I mean, I am extremely excited about what is happening today. And that is the emergence of open platforms, open hardware platforms that's coming down the pipe, right? We recently had Delta Lake being released as a platform, open platform, with almost mostly open source or open with some binary bits, but also freely distributable binary bits. Same thing with Tioga Pass and Monolake with some caveats. And a number of us have all been involved in getting these platforms out there, but I believe more are coming. And so with this huge emergence of open platforms, it's really time to get serious about testing and making sure that we understand the maturity level for each of these things, right? And we'll discuss a little bit more of that in the next slide. Because once you have testing and we agree that standardized testing is important, what are the tests? What is important about what the kind of tests we want? And so I believe these tests should be specific to each of the open source projects that we have. So one definitive test that we've been looking at from the OCP perspective, especially in the open system firmware, is these. In order to pass, we have this idea of a checklist to say, is this platform open? And in a number in that platform, we talk about what are the tests to prove that a platform is stable. And for that is 100 warm and cold reboots. So how do we prove that, right, across all these platforms? And we do that by showing these reboots and building these tests and doing that. But there's a commonality across all these projects, right? As we test each part of an open system, from the moment you do system turn on to the time you log into your system, every part of those things needs to be tested. And this commonality about having open tests is important, because we can check where do we need help, where for which platform. And so the community has some confidence on what is the maturity level for each of these platforms and what needs to be done. And at the same time, we can also check for regressions for each release or each commit and so forth. So this is a sort of thing I'm envisioning and I'm excited about is when we're talking about a common platform for testing. But if you're going to have standardized tests, then it's probably a really good idea to standardize also on what is the testing apparatus across all these platforms, right? So, and this is now we're coming down to the main part of our talk, right? Aligning on a testing harness. The last couple slides were really talking about the need for testing. What are the advantages? And I think all of you understand that already as mature software engineers. But the religious argument of what is the testing harness, what should be used. And so we want to focus on a testing harness or testing apparatus called Contest, which was developed by Meta, which was previously Facebook for a few years. And it's best to be described as a framework that you can adapt for anything. It doesn't force you into any kind of paradigm, but rather what is best for you? What is the best for your platform? What is the best for your project? So at its central thing, it's written in Go, which has been ascendant in the firmware community, especially if you see like Linux boot is written in Go, right? So clearly it's also aligns well with the open source projects that we have today. And so you look at it as a sort of a client server plus device under test paradigm. And the clients can kind of tell the server what to test on which DUT and so forth as a short kind of explanation. But I'm not going to explain that fully. So instead, I am going to have my co-host, Christian Walters, who have spent quite some time working with Contest and actually building a service already. And so he's going to give you a walkthrough intro on Contest and show how it works and what you can do with it and so forth. So I'm going to hand it over to Christian, because on this recording, I hear children running around and I probably won't need to cut it off before anything else. But in any way, I think it's important to understand one final bit from my part is that Contest is already accepted as a testing platform for Linux boot and OCP. In fact, the entire repository for Contest has moved to the Linux boot repository. So for at least two projects, Contest is already part of it. And of course, it's used internally at Meta. So with that said, I'm going to hand it off to Christian, and he's going to continue from there by giving an overview and some examples, how it can be used, and so forth. So thank you, and I hope you have a wonderful conference. And at the end, I will be happy to take questions from the two of us.
Okay, hi, my name is Chris. Thanks, Sriram, for the intro. I'd like to talk about Contest a bit. So I'm trying to give you like a little bit of overview, like how does it look like from a technical side a little bit, and also what kind of scenarios are we working here. What did we enable with Contest basically, and later on, depending on the time, actually, I'd like to show you a little bit of code, go through the job description, probably show you our GitHub client that we have for Contest and these kind of things. Okay, first of all, properties. So if you're interested in like a very deep technical architecture side of Contest, check out the FOSDEM talk by Andrea and Marco on the FOSDEM 2020. And also last year, I did a talk with Andrea together on open source firmware testing on the OCP Delta Lake. There we also go a little bit more into the technical details of Contest. However, want to give you like a very short breakdown of Contest. Contest is obviously open source. Contest is a general purpose framework, so it's not only about firmware or the firmware testing. It's a general purpose testing framework. Of course, it can be specialized with plugins that it is very, very tailor-made to firmware. However, it doesn't claim to be like a special purpose firmware testing framework for firmware. It's modular, and that's the pluggable logic that we have there. Specialized behaviors can actually be plugged in with these plugins. How you can do that and at what points within the Contest infrastructure, I will give you an overview on the next slide. It's validating, so it tries to minimize runtime errors. For example, it checks all the job description before they actually do get executed in order to minimize the risk of you running a test for an hour and then the next test step fails because it's malformed. So it gets validated before actually starting the job. It's configuration based. So that means a job is described as a text config. What that and how that looks like, I will show you also on the next slides. And it can either be run on the device directly, so on the device under test directly, or it can be orchestrated, because obviously not everything can run on device under test directly, that means you can also run it somewhere on a server and only access the device under test from Contest. When we talk about Contest, as Sriram already said, it follows like the client-server paradigm. Contest mostly mostly really and maybe only focus on the server part of the client-server paradigm. So that means you always have a client which somehow injects the job via in a JSON format. However, in the end, all the functionality is in the Contest server itself. The client can be tailor-made, and there are a couple of example clients out there. I don't know how, like a simple HTTP client, for example, and we have a GitHub client, open source, that you can leverage. However, that client side is not really part of Contest itself. It just uses some Contest libraries and or packages within Contest and to post the job description to the server, and then the server takes over and does whatever it does with the jobs. I don't know if you can really see it very, very good in the slides, but all the light boxes, like the light gray boxes, are actually pluggable logic. So that means once a client submits that request via JSON, it gets basically fetched on a listener. That can be HTTP, HTTPS, it can be gRPC. I think Meta also have an internal Facebook Thrift implementation. And it goes through an API to the job manager. The job manager obviously manage the jobs. And then these jobs can be run on targets, right? Your targets are most likely your devices under test. These targets need to be locked so that only one job runs there at a time. And once that is done, so then you have a target manager and a target locking mechanism for that. And you also have a test fetcher, which fetches the actual test that should be executed. Every job can contain multiple tests, don't have to, but it could contain multiple tests. Each test defines multiple test steps that it can actually run through, and a couple of reporters in the end that do report back to the job manager. And as I said, the listener can be plugged in, the target manager, the locking mechanism, the fetcher, the test step, and the reporters can be switched and adjusted to your needs with that pluggable logic. The job description itself is complete. What I mean with that is, like, all the information Contest needs are referenced there. Either they are literally included in the job description itself, or at least reference to where to find them are included. It can be either YAML or JSON. However, in the end, that YAML, so if you look at the code, what the client does, it actually just translates the YAML files into JSON and posts it via, I don't know, HTTPS to the server. So it's JSON under the hood anyways. And it's simple. What I mean with simple is, I will also show you on an example, but basically every job contains various tests, right? And every test can have a couple of steps. And the simplicity here is that either the next step gets executed or not based on if the prior step failed or not. If it failed, like the whole test aborts and errors basically. However, if it's success, it just goes through. You cannot have very complex flows in context that you say, okay, on failure, do this and that, and then do recovery, and then do this and that. That's actually not possible, and that's by design not wanted. That simplicity then also limits your jobs and what you can write, exactly that these parts that I named, that you want to have error cases and say, okay, on an error case, do this, and if you if the test step was successful to that, that is actually not possible. It just either executes the next step or not, and then if it does not execute the next test step, the whole test just aborts. How does these job requests look like? Here, for example, that's a very simple QM boot test. It always follows like the same scheme. You have a job name and a couple of metadata at the very top. That is obviously YAML here. The test description includes like the target manager. Here in that case, we literally write the targets into the job description, and that's why what I meant was complete. Everything is in the job description. Here I just give it IDs, and then the actual test follows. As I said, could contain multiple tests. In that case, it's only one test, and that the first step here is to delete like the old local files that are probably left over from the latest run. Clean everything up so that we can start new. I want to give you two scenarios that we're using it here in our company. One is the OCP Delta Lake scenario, and that is the one that we presented last year at the OSFC. What we did there is we do core boot master upstream testing, so that means that we have a fixed Europe Linux boot commit that we use as a payload, and we do fixed interval or per diff testing on core boot. That means every 12 hours, for example, we take the tip of the core boot master and test that tip, basically, if it builds and boots, and run a couple of tests on these tip. That is, of course, different as to if you have like every commit testing, because it's not that extensive. However, it gives you some certainty that if you build it, I don't know, twice a day and run a couple of tests on these images twice a day, that this image works or not. We push these results to an S3 bucket, so everyone could fetch these results, and in that case, we use the BMC to flash the device under test, which is very, very nice, because on server platforms, most likely you have a BMC, and you can use that BMC as a jump host to test the actual host firmware. Of course, things do get complicated if you want to test host BMC interfaces, for example, because that also depends on the BMC then, and then you need hardware modifications, or you need like a third-party external jump host to monitor this. However, if you only want to boot the server platform and only want to test the host firmware, BMC is a very easy way to go. The other scenario that we use it is also, again, core boot. Obviously, we are very, very attached to core boot. In that case, we build a contest client that listen on GitHub hooks, on webhooks, and it does test every commit that comes in. So what we're doing right now is build a boot testing first on QMO, so in a virtualized environment, and the other one is that we use an Intel CRB. It's an Xeon SP based Intel CRB, and we see if we can boot the current image into the target OS on every commit, right? The contest client, I can post the URL later in the chat. It actually just gets the webhook from GitHub, and the webhook itself contains all the information that we need, like what commit are we testing on, what repo, and these kind of things. And the client can actually pass these information into the job description and then hand over the job description to the contest server, and then the contest server does the rest. Again, we push all the results to an S3 bucket so that we can do metrics on it. We don't do that now yet. However, in theory, that's possible. And we also push the final or the tested firmware images to an internal FTP server so that people, developer, tester can actually take that images as like a known good image and have it run on an Intel CRP, for example, so that we always have an image handy if we need it to boot a platform. Of course, that mechanism basically could also be extended to do regular releases, right? What you could think of is that you say, okay, once you merge something into a master branch, you do a release, or every X months, weeks, days, you do a release and put that image somewhere for people to access. Long term, we want to switch. Long term, we want to mirror first the corporate's current QA system that we have with Lava, which is already integrated into our Garrett system. We want to mirror that with Contest and slowly migrate completely to Contest. Of course, there are a couple of challenges all along the way, especially like hardware challenges. What do we do with non-server platforms if we don't have a BMC? We always have to attach some kind of setup that we can actually control the host. Of course, reliability is an issue. Sometimes, especially if you do hardware modifications, hardware is flaky, right? And it just doesn't work like you want it to work. And sometimes, like the only thing that you can do is like power sequencing thing, and you know, it just works again. However, how do you work around this reliability? And that is an issue, and that is very crucial. Also, because we already have the Lava QA set up, and we want to do the same thing now with Contest, we either have to duplicate the whole setup, or we have to find a mechanism that these two testing frameworks, Lava and Contest, can actually share the same resources. That sounds utterly complicated. However, that could be established if you write like a target manager on your own, which manages the targets for you, and it does that in basically hand in hand together with Lava, right? There need to be a couple of modifications, but in theory, that's possible. And of course, if you want to know more about it, join our Contest Slack. We get a Contest Slack channel on the open source Firmware Slack. You can get your invite at slack.osfw.dev. And just lately, I think it's a couple of months ago, Contest moved from the Facebook incubator repo, where it has been sitting for quite some time. Now it moved into Linux boot. I think that was mostly done because of companies would need to sign CLAs to contribute. However, that is out of the way. And if you want to contribute code, I think you don't have to sign CLA anymore. And with that, let's jump over and see what I can show you else. The first thing that I want to show you is exactly our GitHub integration that we have right now. Here you see like a couple of commits. That's like from the October 5th, so it's now nearly 2 months old. Here you see how it looks like in the end, right? So we get our own private fork of or mirror. So it's not actually a fork; it's a mirror of Coreboot. However, there are a couple of NDA commits in there that we first need to clarify, you know, with lawyers and these kind of things, that we can actually make that open source. However, we do have build testing attached to it, so automatically it hooks up and does build testing on the repo, and also in that case does QEMU boot testing. We also enabled testing on the Intel CRB later on, which basically adds another entry here to that green arrow. I hope you can read it. Let me just zoom it on a little bit. Okay, that does look right. In that case, you see build test binary in S3 bucket. You can actually press the details to get to the S3 bucket, and also here you can press on details, and then you probably get a JSON file which you can open. Let's see how that works. Probably it works, probably it does not. Okay. it should work normally. Ah, there you go. And it gives you like the full JSON report of JSON. Of course, you cannot really read it right now because it's not really formatted, but you get all the details and you get, I think, the concept on how it works. Same goes for QM or boot test. You get the full test report there, and of course here getting the binaries if you want to. The other thing I wanna show you is one of the coreboot SB of the QM or boot test for the coreboot repo, and that is exactly what I meant with, like, it always follows like the same principle. You have a couple of metadata here at the top, like what's the job name, how many runs do you want to do? You can either do it like only once, or you can, I don't know, have 15,000 runs if you want to, which might be handy, for example, if you do boot test or reboot tests. And you can also specify in what interval they should run. Should they run like every 60 seconds, or should they run every 2 hours, or every second, whatsoever. You get the target manager. Here I literally posted the devices that we test into the file. It is very important to know that contest does not really access these devices under test directly, right? You can only have an ID just as a namespace, but you can also put in like an FQDN, where you name a host name, test.9elements.com, and where you can actually access the device. Of course, still contest doesn't access the device directly because it doesn't know how to access it. Why are you actually defining those parameters here at the top? Because you can use them within your test steps then with Golang templates, right? So if you, for example, here we are cleaning up some folders which are under the temp folder, and we are doing that by saying, okay, if for that ID, right, and the ID basically matches to the target ID that I defined up here, if that already exists, please remove that. In the same manner, you can actually clone, for example, things, right? Here we got our GitHub repo that we want to clone. We do clone that into temp, coreboot, SPR, SP, and have a dash with the ID of the target that we later want to test on. So the ID of the device under test. And with Go templating, it gives you the flexibility to actually parse in these names directly into the test. Okay, so that is pretty much straightforward and not really much to see here. So it's a build and boot coreboot test. As I said, now we name all the steps. Every steps also follows like the same principle here. You have a name. The name actually names the plugin that you want to execute. In that case, we want to execute the command plugin, which just executes a bash command on the contest server, so not on the device under test, but on the contest server itself. And we delete the local files. It has a label, so in case it fails, we can actually see what label failed and can see what step failed. And it gets a couple of parameters. That parameters, of course, are always dependent on what plugin you called in the first place. In that case, you have to hand in an executable that you want to execute, and then it's remove, obviously. And then you can also hand in arguments where you have, you want to remove the folder recursively, and you want to remove that folder here. What you can also do, so except you got executable and args for the command plugin, but you can also, for example, specify a dir, a working dir, where that command should be executed. And you can also have like an expect value. So when does that command failed, or when is that command successful? In that case, that command is successful if we see cloning into string, right? And if we see that string, we say, okay, that command was successful. If it doesn't make sense or not, that's on a different paper here now, but however, you can do that. And this is how the whole test is structured. And that is also what I meant was simple. You just execute one step by step. And basically you can break down nearly every test to a couple of commands that you just execute in your shell, right? And if you do that, you can also do it with contests and have that optimized. If you do more complex things, and if you, I don't know, running a test suite and want to evaluate it already, if it was successful or not, you can also do that with your own plugin and pass basically all the output in the plugin and see, okay, that plugin was successful if, I don't know, 80% of the tests were successful, and that plugin failed if 80% of the test failed. So you got a lot of complexity in the end. Contest only wants to know from the plugin you write on your own, was that plugin successful or not, right? And if it was successful, it goes on to the next step, and if it fails, it gets all the error information that you actually output out of your plugin and pass it back into a report, and that report can be fetched from your client again, for example, and you can actually check, okay, what went wrong on my job. Okay, and with that, I'd like to close down here. If you get any more questions, please let me know. I would be happy to host some kind of coding session if you're interested. It doesn't have to be today anymore, but we can also do it like in the next couple of days. I don't know, write your own plugin, or I can show you around to write your own plugin. If you got any questions on the two scenarios, please just give me a message. And thanks for attending OSFC. I hope you had fun until yet, and I hope you have fun for the next talks. And yeah, thanks.